Welcome to the mini lesson for volume of a liquid. Before we start that, we're going to go over the basics again, just a very quick reminder of the basics of measuring in the metric system. So temperature is measured with Celsius degrees. That's different from what we know of Fahrenheit. Length is measured in meters, and then that's the base unit, and then from there we can go to kilometers larger or centimeters, millimeters smaller. Mass is measured in grams, and then we can go larger kilograms or smaller milligrams. And then volume of a liquid in liters, milliliters, of a regular solid cubic centimeters, and of an irregular solid milliliters. Now remember, today we're going to go over volume of a liquid. Tomorrow we'll cover regular solids and irregular solids. And then on Friday you'll cover temperature, length, and mass. So when we're talking about measuring a liquid, we're looking at trying to figure out how much space it takes up. So volume is a measurement of the amount of space. Okay, it's not how much material is there, it's how much space does that material take up. Okay, so we need something that can measure space. Well, liquids are easy because we've got these little things called graduated cylinders, and when you pour it in, it's got little markings on the side, and we're going to do some practice with that today. Graduated cylinders are generally used for small amounts of liquid. Generally under 100 milliliters is what we use a graduated cylinder for. Now, we can go to larger amounts of liquid, and we can't use the graduated cylinder because it's too small. If I have 300 or 400 or 500 or 600 or 795 milliliters, I can't measure that in one graduated cylinder. So if I'm trying to measure all of it together at one time, I'm going to need something bigger, something that measures liters. So what I'm going to use is a beaker. No, wait, that's not right. Well, that's beaker in a beaker, but that's not what we want either. There we go. That's a beaker. And that's how we're going to be measuring larger amounts of liquids. Now, I'm only showing you one graduated cylinder in this picture, and I'm showing you one beaker in this picture. But to be honest, there are, if you were to walk into a science closet, there are very, very small graduated cylinders like the one you see on the screen that measures no more than 20 milliliters. There are a little bit bigger ones that measure 50 or 70, and then there are big ones that measure 100, and there are even bigger ones that measure like 200. Beakers, however, can measure bigger amounts of liquids. So you'll see this one here. If you can see real close there, it says 300 milliliters. So we can measure up to 300 milliliters in that big beaker. Now and beakers come in different sizes too. So we could have a smaller beaker, we could have a larger beaker. So that brings us to measuring using a graduated cylinder. Now I'm not going to go into measuring using beakers because if you remember looking back at this beaker, that's pretty obvious, right? If it's at the 300 milliliter line, it's obvious that it's at the 300 milliliter line. So beakers are not one of those things that we struggle with measuring. What we do struggle with measuring is the graduated cylinder because they don't mark every line. So you kind of have to remember your number line from math class to be able to understand what's being said on the side of that graduated cylinder. Now, here's another vocabulary word that you're going to need to know. The meniscus, meniscus, meniscus. The meniscus is that little dip. So if you're looking at a graduated cylinder like we are here on the left, and you're looking down at the liquid, you're looking and you're seeing, if it was actually a real picture, you would see the front of the inside circle that would be at one mark, and you would see the back, which seems to be at a different mark. So when you read a graduated cylinder, you have to get down at eye level with the liquid, like they are right here, eye level. And if you look closely at a graduated cylinder, it's got kind of a little dip in it. That dip is called a meniscus. When you read the reading on the graduated cylinder, you read from the meniscus. So if you look here, this one is between 60 and 70, which means each of those lines between are going to be ones. So it's 61, 62, 63, 64, 65, 66. 67 is where the meniscus is. 68 is where the edge of the water is. You see that? 67 is where the meniscus is. 68 is where the edge of the water is. You always read from the meniscus, from the center. Okay, so let's do a little practice and see how you do here. Okay, what is the line for the meniscus? Now this one's even more of a challenge because this is in milliliters, and remember we said it's base 10, so everything's done in 10 and pieces of 10. So if this is 6 and 7 is our range, each of these lines is going to be a 0.1. So it's 6.1, 6.2, 6.3, 6.4, the big line in the middle, 6.5, 6.6, 6.7, 6.8, 6.9, and then 7.0. So if that's the case with this graduated cylinder, where is the edge of the water located? What's the measurement of the edge of the water? 6.7, okay. And where is the meniscus? 6.6. So if we count up, do you remember when you're between two numbers like this, 6 and 7, these small numbers, it's going to be tenths in the middle. If we're back here at this bigger one, where it's 60 and 70, it's going to be 1 in the middle. So that's why base 10, that's why metric system is so easy, because we always know between the two numbers is 10. Or between the two numbers is, well, it's still 10, but it's with a decimal in the middle. So it's 6.1, 6.2, 6.3, 6.4, 6.5, 6.6 is where the meniscus is. So let's try a couple more here. Hold on 1 second. This one seems to be off the screen a little bit. We'll clarify that. Okay. Now I'm going to give you about 5 minutes. I want you to pause the video, take 5 minutes, go through and answer each of the questions. And when you're done answering the questions, come back, restart the video, and then we'll talk through these 5 pieces. So you have 5 minutes. Go ahead and pause this and then do your 5 minutes. Okay, welcome back. I hope that went well for you. I hope it wasn't too difficult. Probably the hardest one here is going to be the first one. So if we're measuring from the bottom, you'll notice there's no number at the bottom. So what do you think it starts at? Well, remember what I said, between numbers is always 10. So if it starts at 10, what starts at the bottom? 0. So if we start counting up those little marks, the big mark in the middle is 5, and we keep counting up. Where is the meniscus? Where do we measure number 1? 7 milliliters. Right. Make sure you're putting the unit with the number. 7, small m, capital L. Make sure you're putting the measurement unit with the number. So 7 is the measurement. You need the unit to go with it. So this is 7 milliliters. If you don't put ml, I can go, oh, well, he means milligrams. They mean kilometers. And then I can mark it wrong because technically it's the wrong answer. You've got to put the unit with the number. Okay. Number 2. We count it up. It's between 30 and 40. The big number is 35. The big one without the number between is 35. So we count up from there. 36, 37, 38. 38 milliliters for the number 2. And let's go to number 3. It's between 30 and 40. So we're counting up from 30, 31, 32, 33. And then 4 is easy, right? It's 20 milliliters. Now 5. If we looked at 1 through 4, we're taking the volume of what? We're assuming that's water, right? What is number 5 going to be the volume of? If you said the water and the rock, you would be correct. And we'll go more into this later next week when we start working on mass and volume. But to do this, we're still going to just measure it like we would normally measure it. Okay, so you wouldn't measure to the rock and say, okay, that's 30 milliliters for the rock, because there's space around the rock that doesn't have rock. It's got water. So you can't do it that way. And we'll talk about how to find the volume of this rock, even though it's an irregular object. We'll talk about that tomorrow. So for this one, we're just going to measure both the water and the rock together. What's the volume of the two together? And this one's pretty easy here. It's 40 milliliters. All right. What I would like you to do is I would like you to click on the assignment for today in the independent work. Complete that. Make sure you complete your exit ticket, and then listen for or make sure you check in with Mr. Steinberger about your small groups. Have a great day.